Hi there, welcome back. Welcome back to another video on the Breisgau. I'm nearly finished this project. There's one more thing that I want to do, which I promised originally that I would do, and that is to look at voltages. Now, we have a problem right at the outset, and that is that this radio has only got a 220 volt transformer. I've got to rephrase that. There are various voltages, but the highest one we've got is actually 220 volts. Now, what I'm getting here, and in a lot of Europe, a lot of places in Europe, is the voltages are going up. Originally it was 220, it's going up, and at the moment, right now, I normally measure between 230, 235 here at home. It depends on the time of day, depends probably on the load that the area is drawing, but it's around, say, 230 volts, 235 volts. It can go up as high as 240. And we've actually started mentioning 240 as sort of a norm now. Now, my problem is this radio has got the input expecting 220 volts. If it's getting 235, that's quite a significant percentage above what it's rated for. That means that the secondary voltage provided by the transformer is proportionately higher than what it should be, which means our B plus should be proportionally higher than it's supposed to be. The other thing is our heater supplies go up. Now, the heaters on this radio are supposed to be 6.3 volts, which is quite standard. I wouldn't be surprised if they're closer to 7, and we're going to measure that in a minute. But what we need to do is to see what needs doing to bring those voltages down. Now, there are many ways of doing this. The most common way is actually to put in a resistor in line with the supply. You can do that on the primary or the secondary, depending on what you want to reduce. In my case, I want to see what it is that I have and what voltages I want to reduce to, so that I can see what the best way will be to make that drop. If I put a resistor at the input of the primary, I'm just right at the mains voltage. It's high voltages around there. Well, I've done it before. It's not bad, but it's there are better ways. If I only want to reduce the B plus, then I should think of doing it after the rectifier. But then we come to the second situation, and that is I want to probably replace the selenium rectifier. And the selenium rectifier in these old radios has quite a high voltage drop across it. Whereas if I replace it with a silicon diode bridge, the voltage drop will be maximum 1.4 volts. So I could end up with a B plus higher than I want. And that's something I need to be careful of or pay attention to so that I don't give it too high a voltage when I try and drop it. So this is it's actually a contradiction. You try and drop the voltage and you replace the selenium rectifier and you end up with a high voltage. So it's kind of stupid, but that's how it works. So let's have a look at this and see what voltages we're getting and see what it is we want to achieve. I've got these multimeters ready, and what I want to do is I want to switch on the radio. This one here is measuring the actual AC supply coming in, and the reason I'm measuring this is that I realized my meter on the dim bulb tester is actually reading a bit low. So what I have here is I've got the radio on, and what am I reading here? Oh, that's supposed to be positive. Yep, okay. What I'm reading here is the mains input. 212 volts. I've got 208 on the dim bulb tester. The limit is still on, but all the bulbs are on. So I've got, about 200 watts light bulb in there. And 211, 207. Now if I bypass the limit, my dim bulb meter there tells me it's at 227, whereas the actual voltage coming in is 232. So that's what I'm working with, a main supply in the order of 232, okay? Call it 230 to 235, thereabouts. And what I'm actually getting at the B plus is 277. Now, what is this supposed to be? Well, actually the B plus, according to the schematic, is supposed to be 282. So, hey, everything's fine, right? We've got a higher voltage than we need. We've got a lower voltage than we need. It's not too far off. We could actually leave it at that and it'll be quite happy. But something else is wrong here. We've got to take into consideration something else. And that is, we've got to take into consideration that perhaps this voltage is low because of the selenium rectifier. And if this one is high, there's one other voltage on the radio that we need to pay attention to, and that is the actual heater voltage. Now let me get the heater voltage, measure the heater voltage, and see what we get. We'll do it on this guy, on little brother. AC volts. And what are we getting here? There we go. 6.7 volts. That's supposed to be, is that right? Yeah, 6.7. It's supposed to be, why did that suddenly drop? Oh, somebody must have switched on a big machine in the building. That's supposed to be 6.3, so that's a little bit high. So logically, before I do anything else, what I need to do is drop the voltage that the secondary of that transformer. In other words, I need to try and bring that transformer to accept 230 volts as normal as opposed to 220. And I could simply put a big resistor in line, probably, I don't know, 30, 40, 50 ohms, thereabouts, in the mains line. And the current being drawn, which at the moment over there tells me is about 300 milliamps, that would, 300 milliamps, 50 ohms, would come to drop about 15 volts. So, it's probably about there, 50, 60 ohms. But that's not the way I want to do it, because that creates a lot of heat. There's another way of doing it. I want to drop this. I want to make the radio or the transformer expect 235 rather than 220 and give me 6.3. And then I will look at what the secondary of the transformer is giving me and what the B plus is, and decide then what to do about the selenium rectifier. All right, let me show you how I decided to go about this. I mentioned right at the outset that this transformer offered us an opportunity because of the way it was built. And that opportunity is that we could actually wind more wires around it. And the reason is there's actually a gap at the top here and at the bottom here that you can actually put wires through. Now, what we have here is the mains is coming in and it's creating an electric field, and then all the other windings take off from that. That's where we get the secondary voltage, we get the secondary main supply, we get the heater supply, and you can actually wind another winding around it, which is what I've done here. Now, the way to do this is you figure out how much you want to get, and I wanted to get about 15 volts, and you'll see why in a minute. But you figure out how much voltage each winding gives you. And the way I did that is I wound 10 windings around here, and I ended up with about 2.2 volts across 10 windings. Now that's unloaded. So I figured each winding gives me 0.22 volts. Then I figured how many windings, how many turns I needed to get on here to get 15 or 16 volts. And it came out to about 70. And that's what I did with this wire. Now this is that enameled wire. It's proper for winding transformers. I had some lying around, and then I started winding. And believe me, it's not fun. I put 70 windings on here, and you got to literally pull all the wire through. It's about 17 meters of wire lying on the floor. It sometimes gets tangled up. So this was not fun. In fact, I regretted it very soon after I started it. But then, you get stubborn and you figure you've wasted so much time, you might as well go through with it. So I wound 70 windings on here, and I now can measure how much I'm getting on there. So I've connected the multimeter to that winding. It's just these two wires coming off here. And if I switch it on, I'm getting about 16 volts. In other words, for about 230 volts going in, I'm getting 16 volts coming out here. Now, how can I use that to control the voltage that this thing is giving me? Well, what I can do is I can literally put that coil, that winding, in series with the original primary. Now, what will that give me? Well, if you know a little bit of transformer theory, you know that the ratio of the voltages is equal to the ratio of the turns. So the primary voltage divided by the secondary voltage is equal to the primary number of turns divided by the secondary number of turns, okay? Which means that if you put more windings, more turns on the primary, you are going to create an imbalance on that formula, and you're going to drop the secondary, okay? Because there's more turns on the primary side, same number of turns on the secondary side, same voltage coming in on the primary side, that means your secondary voltage has got to go down. And that's what I want to do here. Now, there's one thing you have to be careful about. By the way, the reason I do this on the primary is because this will affect both of these other windings, the secondary winding and the heater winding. So if I do this on the primary side, I actually reduce the voltage on the secondary or the main secondary, and also on the heater voltage. And we'll see how we do that. But we have to be careful because we've got to wind this in the right polarity. If I put it the other way around, it actually defeats the object. It'll actually probably increase the voltage. So what I'm going to do is I'm going to solder these two wires. The easiest place to tap it into will be at the fuse, because this wire here is the one going to the transformer after it's gone through the voltage selection. So if I desolder this wire here and I solder these wires into there, so in other words I put it in series with this point here, I'm adding those windings, those 70 windings, to the primary winding of this transformer. Okay? And the way to do this safely is I'm actually going to put restriction on the dim bulb tester. I'm going to add quite a bit of restriction. I'm going to limit, and I'm going to put a lot of, well, not that much. I'm going to put a lot of restriction on there. I've now only got 100 watt bulbs on there, total of 100 watts. So I'm going to put the meter on the heater voltage, which is easily accessible, and I'm going to solder this one way round, see what the heater voltage comes out at. I know that even if it works in reverse, it's not going to be a problem because my dim bulb is reducing the voltage that the radio is seeing, so I'm doing it safely. Let me set that up and see what we get. So I've wired that up one way, and let's look at this. This is the heater voltage. Let's see how much we get on here. 4.5, 5.1. It's dropping a bit as the tubes start drawing current. So 4.9 volts. Okay, switch it off. I'm going to reverse that and see what we get then. Be careful, you're working with high voltages here. Make sure you know what you're doing. Okay, let's see what we get now. I think it's the other way, right? So the other way was, I believe, correct. Let's just put it back, make sure everything's off. Okay. Now we're measuring the heater voltage with that guy, and we're going to use little brother to measure the B+. Okay, let's do it again. Now remember, I've got the restriction on, so let's put that on. It's supposed to be DC volts. Right, there's our B+, 197, 196, 4.8 heater voltage. I'm going to reduce the restriction. I've got another light bulb in there, 5.6 volts, 224, another light bulb, 5.8, 235, and I'm going to now bypass restriction completely, and look what we've got. We've got Nero's down at 6.3, which is what we wanted on the heater voltages, and we've got a lower than what we wanted B+, 253. Now, this is a problem with the selenium rectifier, which if I now replace it with a bridge rectifier, we'll see what we get. So what I'm going to do now is I'm going to tidy this all up, make this all safe, leave that in as permanent, and then I'll get to work on the selenium rectifier and see how we get along with that. Okay, it's another day and the saga continues. I've wired that up more or less correctly. More or less. Yeah, I've wired it up properly. I've made sure that I'm wiring this in after the fuse, so that if there's a short in here, the fuse should blow first. That's just a little detail which could be important. And then what I did is I worked on the selenium rectifier. I stuffed it with 4 diodes, 1N4007s. So I've done that before, and I'll link a video above where I show you how I do that. The 4 diodes fit in there, creates a diode bridge, just like we have there. I have everything wired up again. Make sure you don't get those wrong. I've left the heat shrinking loose so that I can measure. I've got the meter on the B+, or rather on the positive coming out of there. That's our first B+. And now we're going to turn it on and see what we get. Got the meter on positive volts. That dim bulb test is on just with the 1 lamp, 40 watts, so heavily restricted. That's always advisable when you're switching it on for the first time. And I'm going to switch it on. As expected, the light comes on quite brightly because of the restriction. We've got 180 volts going up, and it'll come down as the tubes start conducting. I guess it's stabilized. Coming down a little bit. There we go. I'm going to give it another light bulb. So now we've got 100 watts in there. 250, 240, 230. Okay, we want 282. So let's carry on. 3 light bulbs. That's now 140 watts in there. 260 volts. I'm going to give it the final light bulb. 272. Okay, we're 10 volts below what we want here, but we're only seeing 210 volts. Now, taking into consideration that thing's reading a little bit low, this radio is seeing about 215 volts because of the restriction on there, and we're getting 270 volts. Now, if I bypass this, this thing could shoot up quite high, so I've got to be ready for it. Oh, okay, put the volume down. Now you see that's a 225, and this thing's seeing 294, so it's a little bit high. So I need to reduce that. All I need to do now is reduce the B plus itself. I don't actually want to reduce the primary. The primary is fine because I wanted the heater voltage down to 6.3, which we checked yesterday and we got. So now I know that the primary is prepared for 235 volts, okay? And it's producing what it should produce. Now it's producing a high B plus because the selenium rectifier voltage drop is actually very low. So what I need to do is now I'm going to work with a resistor. I'm going to experiment with a resistor in series with the B+. So coming out of the positive of the bridge rectifier, I'm going to put probably a 10 watt resistor, and I'm not sure exactly how much voltage I need to drop on the B+ to get it down to 282 or 280, but because it is sort of variable, it's a feedback situation. You don't work out exactly what current you've got and how many volts you want to drop. It's more or less, because the voltage the tube see will determine how much current it draws, so it's sort of backwards and forwards. So what I'm going to do is I'm going to try with about 40 or 30 something ohms and see what we get, and we take it from there. Let me try that. I've got the red crocodile clip connected to the positive of the bridge rectifier, going to a 100 ohm resistor, 5 watts. The black croc clip comes out of the resistor to the wire that goes to our B+, that is our B+. the meters connected to that point. And we'll see what we get. Let's switch this guy on. I've got the limit on. I've got all the lamps on there. And as expected, it's high because it's still heating up. So let's see what we get. Okay, it's coming down. Now what I need to do is to bypass this guy. Let's let this stabilize a little bit. Yep, okay. Bypass it. Damn, that's close. 280. Looks like that is exactly right. Well, I think we've got it. I think 100 ohm is about right. If I wanted to raise that a bit, but you see that there's reading 230, so it could go up to 235. So I think 100 ohms is perfect. Now, is 5 watts enough? 39, 40 degrees. That's not bad. I'll leave it for a little while and then feel it. I don't want this thing to toast up too much. The alternative would be to put a 100 ohm 10 watt resistor, which I might do. And I need to put that onto the chassis, maybe even clip it down so that it uses the chassis as a heat sink. And I think we're there. Okay. All right, I'm back. There's a slight change. I've put a 120 ohm 11 watt resistor here. I've clipped it to or connected it to the chassis, so we've got a bit of a heat sink here. This won't get as hot as the other one, but we won't take any chances. So it's coming out of the positive of the selenium rectifier through the resistor, and then it goes off to the capacitors. So we'll measure the B plus over there. There's a little bit of wire sticking out. Everything else has been heat shrunk, so we don't create more hazard. And I'm going to switch it on and test it now. Now I've got the dim bulb tester on. All the light bulbs are on, but the limit is still on. So we've got a little bit of limit. There's a basically 200 watt light bulb. Let's hit it. And I'll measure the B plus. It's going up as expected. And it starts coming down. Okay, to about 260. Now we've got that limit on, as I mentioned. Let me just put the volume way down and I'll bypass the limit. So there's no limit now, and we have 278 volts. Now that is damn close to 282. So I'll call that a success. And if we look at the heater voltage, I put that on AC volts. Let's look at the heater voltage. Oh, come on. .34. That's good enough for me. So what have we done here? We've basically solved the problem of the heater voltage being too high by reducing or by increasing the number of turns on the primary. So we've made this a 235 volts transformer when it was actually 220 at the maximum range. We've got the B plus, or rather we've got the secondary that goes to the heaters producing 6.3 something, which is closer to what we want of 6.3. So that's good. And then we had too high a voltage coming out of this, which is the converted selenium rectifier. Is producing a much higher voltage over here. In fact, we can test it. Let's see what we've got. Can't really get it. Nah. Not getting in. Oh, 290. Okay. It's producing 290, and then we get this thing is going through the resistor, and we're getting that 200 and now it's a 282. Brilliant. So we've got that resistor limiting the B plus, which is what we want as well. And it looks like everything is hunky-dory. So that was just a little demo. It took me ages to wind the bloody thing, but I think it was worth it. That was just to show you how you can actually arrange for the transformer to handle the higher voltage that we have these days. Now, some of these transformers actually have a 240 volt tapping or winding. So you sometimes don't need to do this. And all they have in there is basically what we have here. The 220 watt winding comes out, and there's another part of the winding that adds turns to it and gives you a 240 volt option. Unfortunately, we don't have it here, so we've created it. Brilliant. I think that's it for now. And I think this project has actually more or less run its course. I'm not sure what I'm going to do with it. I really don't know. Having it open like this does make it more interesting, if a hell of a lot more dangerous. I mean, you've got 220 volts right there, 235 volts right there. So I need to figure out what I'm going to do with this. I was thinking of building a acrylic case and leave everything transparent, and that looks quite cool. But I'm not sure. I'm going to put this on standby for now. I think I've probably taken as much out of this as I'm going to enjoy. So I'm going to call this project finished. And for those of you who've stuck around with me for this project, I want to thank you for your patience, for your attention, and for your comments. By the way, do comment if you want to, and I don't care if they're good comments or bad comments. I've got a thick skin. The comments always make the interaction, the videos, a lot more interesting because people get things from it. A lot of you comment, a lot of comments I answer just about every comment. But people do tend to learn from everybody else as well. I learn from them. So if it adds to the value of the video, I'm all for it. So I'm actually sorry this project's coming to an end. I really enjoyed this. I enjoyed the complexity of the set and the various stages that we were able to go through, because I did need a bit of a recap on some of this stuff. So I hope it's been beneficial. So I want to thank you for watching. If you've enjoyed this, please click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Once again, thanks for watching. Bye for now. Stay safe. Oh, and by the way, I'll be starting another restoration very soon. This time it's a Telefunken, one of my favorites, after the SABA. So it should be fun.